My name is Nikitan Dobaria, and here we are discussing basic electrical engineering, and in which specifically we are discussing chapter number 3, transformers. And in our previous video, we have discussed two types of transformer over here. First one was ordinary transformer, means two winding transformer. And lastly, in our previous video, we have discussed auto transformer. And in our this video, we are going to discuss next transformer, and that is three-phase transformer. Whether you consider distribution system or our generation system, in every series, normally we use three-phase transformer. And so it is a very important part of our power system. And when you design three-phase transformer, we can design three-phase transformer. We can construct three-phase transformer in two ways. That will be discussed in our next slide. But in short, we can design three-phase transformer in two ways. We can separately consider three single-phase transformer, and by combining those three single-phase transformer, we can design a one single three-phase transformer. Or you can construct three-phase transformer using a single body, means you can say a single bank. So here we will discuss both type of structure over here. They have their own advantages and disadvantages. Here, one of advantage of both type transformer mentioned over here. When we use single bank of three-phase transformer, so if you compare the efficiency or maybe output of that particular machine, so that will be higher with compared to another type of machine. But when we use three individual bank, what is bank over here? Bank, that is one structure, as we have discussed in the construction of ordinary transformer, means single phase two winding transformer. When we design a transformer, basically we will have a one core, and on that core we will wound the two windings. So that will form a one body, means one bank. So here, if we use this kind of three single phase transformer, three individual bodies, that is known as the three individual banks. And by combining those three banks, if you design the single one transformer, one common body, so that will form a three-phase transformer. So when you combine these three banks of single-phase transformer and design a three-phase transformer, so what are the advantage of that construction? If there will be any fault or any problem in one body, so you can just replace that one particular portion, and if you can easily do maintenance or repairing or replacement in that case. So that is suitable in this case. So this is the how we can construct three-phase transformer. Again, let's understand the construction of three-phase transformer. For that, here one figure is given over here. Let's consider that as when we had discussed the construction of two winding transformer for single phase. So what was the basic structure? There was a one square bank, means there was a one square core body, and on which on this vertical section. So on vertical section we had wound a winding to form a transformer. Same way, here we are going to design three-phase transformer. So basically, what can we do? We can use that type of three bank. On three banks vertical section, there will be windings wound on that vertical section, means on limbs. So here, this diagram is representing this kind of three sections over here. But what we have done over here, we had combined one individual section of each three banks at one place, at a common place. So here in this diagram, if you want to form a one phase, so here you can consider this one phase over here. Now if you want to form another phase, so there is another section over here at 120 degree, and same way you can form a third phase or third section over here. And when you have to wound a winding, so on this first section we will wound a winding of first phase, means let's say R phase. On second phase we will wound a winding of second phase, means you can say B phase or maybe Y phase. So second winding will be on this vertical section. Same way, on this third section we will have a third winding or third phase. But as we had discussed in three-phase circuit, If we add the three component of three phases when they are in balance, you can consider voltages or maybe current. As an example, if we have three phase circuit and three phase voltage, VR, VY and VB. And if we add these three components when they are in balance, VR plus VY plus VB. So same way if we do with the current component. So what will be the addition of these three components? That was derived in our three phase circuit, and we know that addition of these three compounds when they are in balance condition means they are having same magnitude as well as they are on same angle difference. So addition of those compounds is going to be 0. So that was mentioned over here. When supply will be provided to this three winding, there will be three fluxes of three phases. As an example, here we had considered A, B, C phase. So we will have three fluxes phi A, phi B plus phi C on this individual sections. So when this flux will produce in this individual particular section, and they will flow from this path to this path, so all fluxes will meet in the center portion on this center vertical limb. So what will be the total flux on this center limb? That is going to be phi A plus phi B plus phi C, and as if they are in balance condition, so addition of this three is going to be 0. So that means how much flux will be in this middle section? So that is going to be 0. So that proves that if we use this middle section or if we don't use that middle section, there is no meaning of that middle section. So basically, you can just take the three vertical sections directly. There is no need to provide that vertical section which is in middle path, as flux in that path is going to be 0. So when you want to form a single bank of three phase transformer, you can just consider three vertical limb of individual phases and you can construct a three phase transformer. And as we had discussed in our previous slide, we can form three phase transformer by two ways. First one was by combining three single phase transformer. So here in this upper diagram, we have three individual single phase transformer, and in individual bank we have a primary winding as well as secondary winding. So same is given for another one. So now by combining these three single phase transformer, if you want to design a common three phase transformer, what can be done over here? You can consider primary of all these three transformer, and you can connect these three primaries in form of a star or maybe in form of a delta connection. So they will form a star or delta connection. Basically, they will form a three-phase circuit. So same way, you can form this star or delta on secondary side also. So you can connect three secondaries on maybe in form of star or in form of delta. So basically, on primary side we have a star or delta connected three-phase circuit, as well as on secondary side we have a star or delta connected three-phase circuit. So basically, this will form three-phase transformer, or as we have discussed in our just previous slide, what we can do over here, we can form a three vertical limb as one diagram was shown before, and on each vertical limb you can wound a winding of individual phase. As an example, if you observe the second diagram, here we have three vertical limbs, and on this one or first vertical limb we have two winding, primary and secondary of our first phase, same way primary and secondary of second phase, same way primary and secondary of third phase. So basically, again you can connect this three primary in form of a star or maybe in form of delta. Same way you can connect this secondary in form of a star or in form of a delta. So this one common body will form three phase transformer. So this is the two method for us how we can form as a transformer using three individual single phase transformer, or using a common body. And as we had discussed in our first slide, they have their own advantage and disadvantage. And as we discussed in our previous slide, we can connect primary and secondary in maybe star connection or maybe in delta connection. So based on various types of connection, we can have a different type of three-phase transformer. As an example, here, first one, we can connect primary side in form of star connection and secondary side again in star connection. So that will form star connection. Same way, we can connect primary in star connection and secondary in delta connection. So that will form star delta. Same way, we can form delta to star, or lastly, we can form another type of connection, that is delta to delta. So these are the various types of three-phase transformer based on their connection. So this was the construction of three-phase transformer. Now, if we discuss how this three-phase transformer will operate, so there is no difference in working principle of three-phase transformer. It was exactly same as we had discussed for single-phase transformer. As we had discussed in single-phase transformer, when we will provide supply to primary winding, it will generate magnetic flux, and that magnetic flux will be linked with secondary winding. And due to that variable means alternating flux, in secondary winding, EMF will be generated, means we will get output on secondary side. So this same working principle can be applied on three-phase transformer. So as there is no difference in working principle of single phase and three-phase transformer. So that is not again discussed over here for three-phase transformer. You can consider same theory when we discuss for single-phase transformer. So this was all for three-phase transformer. Here we have discussed the two types of construction for three-phase transformer. So thank you for watching this video.